And now, enjoy Jochen Lillich with the track Monitoring Love with Sensu. Enjoy.
Hello, welcome to an hour of Monitoring Love. So let's dive right in. Sensu. Chris already mentioned it in his introductory talk yesterday. Sensu is a monitoring framework, or sometimes it's called a monitoring router, because it has the core functionality of what every monitoring system needs, and it's very extensible from there on. So why should you use Sensu? Well, it's time to get out your bingo cards. First of all the cool kids use Ruby, right? So Sensu is written in Ruby and in very clear and readable Ruby as well. So it's easy to understand. It's easy to take part in development. And not only does it use Ruby as a programming language, it even uses JSON as its configuration format. So you have everything you need today in the 21st century. Third, Sensu is web scale. It's really scalable, and that is one of the core advantages of Sensu. If you have a growing or very dynamic infrastructure, that's exactly what you need. As I said, Sensu is very extensible, and you can write plugins for Sensu in any common language. You can use Bash scripts, Ruby, Python, everything you're familiar with. And even better, you can use the original NETWAYS checks for Sensu. So it's very easy to switch, for example, from NETWAYS to Sensu by simply reusing the checks you have already in place. Sensu can not only collect checks, it can also collect metrics that come with these checks and can then route them to a metrics collection system like Graphite. So here you have a single central instance that collects everything you need to know about your infrastructure, and that makes things much easier. And last but not least, Sensu has a great community of developers and users, and it's easy to get feedback, to get help, and things like that. A little bit about myself. I'm Jochen, and in 2010 I started my current business, Freestyle IT. Our main product is a managed hosting platform for Drupal and WordPress called Freestyle Box. And as every successful hosting platform, it's growing and growing and growing. We started monitoring the system by using NETWAYS, of course, which was even easier by using the Chef cookbook for NETWAYS. Things went quite all right until we hit a certain size of infrastructure, and then things got ugly. We hit load problems, queuing issues, checks were waiting for minutes for their execution. I think many of you know that situation. And as Chris mentioned in his talk, that's the main source of the hashtag monitoring sucks. In 2012, I was lucky enough to participate in DevOps Days Rome, where Ulf Mansson created the opposite hashtag MonitoringLove after experiencing how Sensu solved many, if not all, of their issues. And that's when I became aware that there is a good alternative and started looking into Sensu. And when we hit all these limits of NETWAYS, we started using Sensu and gradually switched everything over, and we are happy campers since then. So when I'm talking about Sensu, I'm talking about Sensu Core, the open source version of Sensu that's freely available under the MIT license. It's been created in part-time work by Sean Porter at Sonian. He later went to heavy water operations, where he is now maintaining Sensu full-time. If there is a Sensu Core, there is, of course, also a Sensu Enterprise. The only difference to Sensu Core is that configuration is not stored in JSON files, but in XML files. No, Sensu Enterprise. Sensu Enterprise has improved performance since they are running Sensu Enterprise on JRuby. It can, for example, convert metrics formats. It has a lot of third-party integrations out of the box, and of course, Heavy Water offers commercial support for that product. Installing Sensu is really easy because they've chosen an omnibus package to where everything that Sensu needs to run is contained in a single package. You install that, and you have everything that's necessary to run Sensu. As I mentioned, configuration is stored in JSON files, which are quite easy to edit. And of course, it's highly recommended to automate installation by either using the Sensu Cookbook for Chef or the official Puppet module maintained by Porter Tech himself. Automation is not only handy because it saves you time, it also reduces errors. For example, the typical thing that machines get provisioned without getting added to the monitoring system. So if you are using Chef, there's a great cookbook. That's what we are using, and the Puppet module does the same. Let's take a look at the architecture of Sensu. By the way, who knows where that is? Dublin. It's the Samuel Beckett Bridge, and behind that, the Dublin Conference Center. Both very nice pieces of architecture I enjoy every time I'm there, which I'm quite often since I live in Ireland. It's quite easy to understand how the components of Sensu fit together. Mainly there is the Sensu Server and the Sensu Clients. The server is a central instance, and on each machine you'd like to monitor, you simply install the Sensu Client. And in the middle there is the heart of the whole Sensu infrastructure, a message bus. They chose RabbitMQ for that. Everything is talking to that. And there's also an API you can use to access Sensu data. Sensu is very simple in that, but there are a few very clever architecture decisions in there. First of all, using a component as the heart of the system that makes everything asynchronous. Everything that Sensu processes is put on the RabbitMQ message bus, and all components talk to that bus and either publish information to the bus or consume information from the bus. That's everything there is, and that solves so many problems. It's fucking obvious on one part, but it's genius on the other. The Sensu Server has as its main responsibilities orchestration of check execution. So the server decides, okay, another minute has passed and it's time to do disk space checks. It simply publishes the check to the message bus. Everything who feels invited, executes the check, and puts the results back. These results then get processed again by the server, and then certain event handlers are triggered that do something with that information. On your monitored machines, there's the Sensu Client, which automatically registers with the server, so you don't have to update your server configuration every time you add a new client. You simply start the client application, the agent, which connects to the server and gets registered automatically, makes things much easier. Even if there are no checks to process, the client submits keep alive information. So that covers outages in the way that if a client doesn't publish something within, by default, 180 seconds, 3 minutes, the Sensu server automatically creates a critical event. Then, of course, the main purpose of everything is that the clients receive check execution requests, which they process, or the client can also schedule checks locally without any request from the server. Either way, it executes these checks and publishes the check results back to the message bus. And if you want to inject custom information into the system, you don't have to create a RabbitMQ client. You can simply talk to a certain TCP port on the client, and this information will be published as well. I'll get to that again later. It's quite obvious what the API does. It's a REST-like interface that you can query and get event data, agent data. You can trigger checks manually. You can resolve events or silence checks. And this API, of course, is also used by a number of dashboards that are available. The initial dashboard was quite sparse. It's now been replaced by Uchiva, which comes with the Omnibus package, and there's also Sensu Admin, an alternative dashboard that you can use as well for listing checks, listing results, seeing what clients you have, resolving events, or silencing checks for a while. Speaking of checks, Sensu checks are, as I said, executed by the Sensu client and are distributed with a subscription concept. So it's quite easy for the server to trigger a check. It simply says, all right, all you web servers out there, please check if Apache is running. That's the single message that the server issues. And now every client that receives that request can judge by itself, am I a web server? That's, of course, part of the client configuration. And if it is part of the web server group, it'll execute the check. So it's not that if you have 200 web servers, you need to send 200 different check requests. Only one single check request is published and then executed by your 200 servers. That makes things much easier, and of course it reduces load on the system enormously. Check results simply use the Nagios protocol, so everything you have to do with your check is return information that's in the format that we are used to that we have been used to for years, and that makes developing new checks very easy. Normally, events are only triggered if checks return a non-zero status, but there's a special check type namely the event type that always triggers an event. That's necessary, for example, if you like to collect metrics. Metrics checks, of course, need to be processed every time, even if they return a 0 status. So you can do that as well. And it's easy to have client-specific values in your checks. So if there is something in your check that varies with each client, some kind of password or some kind of limit, you can put that into the client configuration and simply put in placeholders in the check command. I'll give you an example soon. There are mainly 3 different ways to schedule a check. First of all, standard checks are always scheduled by the server in the way that I've described. Then there are so-called standalone checks, which are triggered by the client itself without any intervention by the server. And of course, you can do manual checks as well by simply triggering them via the API. And that's how a check configuration in Sensu looks like. It's quite easy to read. There's the disk-free check. It's of the type status, that's the default type. Then you have the subscribers, which are the machines that you'd like to execute this check. In that case, it's all, and by giving all clients that subscription, you can make sure that all your clients will execute that check. You can say which handlers should be used to process the results of this check. And then there's simply the command that needs to be executed on the client. And as you can see here, these parts with the many colons, these are placeholders that will be replaced on the client with client-specific configuration values. So in that case, I can define different warning and critical levels depending, for example, on storage size. And then there are the additional configuration keys that you'd expect. For example, the interval in which this check needs to be executed every 60 seconds. And there are the usual additional things like I'd like to trigger an event only if that check, for example, fails 3 times in a row. So you have the occurrences key, or for example, there's a refresh key that says, okay, after a check is failing, when should it be executed again? You can lower your interval in that case, or you can increase it as you want. And there are also additional values you can provide if you'd like to process flapping checks. For example, there's a low flap threshold and a high flap threshold, things like that. That's in the documentation, of course. If you'd like to automate that configuration, you can, for example, use the Chef cookbook, and that's how a check looks like in Chef. You simply define the most core things, like the command to execute, the handlers that are responsible for processing this check. In that case, we are using a standalone check that will be triggered by the client. In that case, probably because there's a client-specific password that I can't put in a central location. And that check gets executed every 30 seconds by the client, which will then publish the results to the bus. There's also metrics checks. For example, in that case, I have a simple script, load metrics, which will provide me with the 3 load values of my machine. And that check will be executed only by those clients that subscribe to the production topic, and it'll get executed every 10 seconds. The script is very simple. It simply outputs a metrics path, the value that's interesting, and the timestamp. And in that case, the script returns with a 0 exit code, which makes it necessary to execute that check as a metrics check, so that handlers will be triggered actually for each metric. And as I already mentioned, it's also possible to publish external events from anywhere you want by simply providing your check details to port 3030 on the client. That makes publishing extra information very, very easy. You can do that from shell scripts, you can do that from applications, anywhere you want. And there's a useful application of that. With the Sensu shell helper, it's easy to integrate everything with the Sensu client that's available on GitHub. Talking about events. What happens in Nuremberg stays in Nuremberg. Events get processed by handlers. There are a bunch of different types of handlers. The most common is the pipe handler, and it does exactly what you probably think, because it takes command output from standard in and then processes the data. It simply executes the command, gets back the data in the normal NETWAYS format, and then passes it on. Alternatively, there are the TCP and UDP handlers that can write event data to a TCP socket or a UDP socket. Transport handlers are for publishing event data to a Sensu transport. For example, the RabbitMQ message bus. There can be others as well. And there are handler sets that make it possible to either simply alias a handler with a different name, or you can actually group different handlers into one name that you then can execute with a single call. All these handlers are executed on the Sensu server and can then trigger additional things. Of course, there are a bunch of common event handlers. For example, the default is simply send an email with that information. There's been a failure, there is a warning, or the event has been resolved. And there are also, of course, integrations with existing services like PagerDuty. You can pass on metrics events to Graphite, for example. Or if you are into chat ops, you can publish events also to IRC, to HipChat, or what we are using at FreeStyle.IT is Slack. We like that service a lot because of its many integrations. And that's an example how that looks like. So it says PagerDuty triggered an incident that came in from our external pingdom check and says that the scotlandreferendum.info website is down. Well, with that result, I'd be down as well. There's also the possibility, of course, to write custom handlers. So one idea we had recently was to create some kind of self-healing for certain events. We simply have a Sensu handler that takes the failed check, decides if something can be done with that automatically, and then a serve message is triggered that executes something on the host that has the failed check. For example, you could restart the service or try to remove duplicate entries from your MySQL replication, things like that. So you get some kind of self-healing automation. And it's quite easy to write handlers. In that case, that's a handler written in Ruby. So the only thing that's necessary basically is to require the JSON gem to be able to parse the data that comes from Sensu. That'll get parsed here, and the only thing that handler does is create a file with the event data in it. And instead of that, of course, you can do anything you'd like with that. You can parse the data, look into it. You'll get all the things that you need, the host name of the client that generated the event, the details, everything, and then you'll simply react to that. It's easy to configure as well. You simply say, okay, I've got my file handler here, and I'd like to use it as a pipe handler that gets the data via standard in and then does something with it. Any questions so far?
The command is actually an exec, or can you
write the command handler in any language you like, so that this command is just basically an alias for exec?
The command will be executed by the Sensu Server, and it can be written in any language that's possible to execute on that server. So, of course, you'll need to have Ruby installed in that case, but you'll have that anyway since you're running Sensu.
But you could also use Python or whatever you like.
Yeah, of course. And especially the pipe handlers make that very easy. You will simply have to read from standard in, which every language we use here can, and then you'll do something with that information the handler receives. It's really simple as that. That's the main thing with Sensu anyway. Things are really simple. It's a simple architecture. It's very simple how it works. It's easy to extend, and that's what triggers the MonitoringLove. It's also easy to access Sensu's API from the command line. There's the Sensu CLI command line interface that you can use to access the API. For example, here I'm resolving an event for a certain server. If I've deprovisioned the server, I can simply do a Sensu CLI client delete, which will remove the client from Sensu, and so there won't be any down alerts if I power off the machine. And there's also a possibility to silence certain clients or certain checks as well. In that case, I'll simply silence the server completely, and I'll also give it a expire time of 3,600 seconds. As I said, there's also a chat integration, and there's even a U-bot plugin that you can use to access Sensu directly from your Campfire chat, your HIP chat, or your Slack. For example, I can give the bot the command, list me all the current events, or I can also filter these events by their severity or by a certain subscription. The next step after having a smoothly running monitoring system is to monitor your monitoring system. Of course, there are the usual ways to monitor the different components. So you can, for example, check if there's an actual Sensu Server process on your machine. You can run the Sensu Client from Monit, for example, to make sure a client is running on every machine and gets restarted automatically if it vanishes. You can check the API by simply doing HTTP checks. And of course, you should especially monitor the heart of the system, which is RabbitMQ, and especially the ready queue, so you can see if there's some kind of congestion and if messages on the bus start piling up. So you start to feel monitoring love. You are happy that things are running smoothly, that checks are getting executed exactly at the time you'd like them to run, not 5 minutes later. Things are going well. Your infrastructure grows. There are more clients that publish checks to the system. And your monitoring starts to show certain symptoms of load effects. So how can you scale Sensu? Well, if you are simply using a single Sensu installation, you can scale the Sensu Server. That's the main component. And that's quite easy by simply adding an additional Sensu Server on a different machine. Master election between these servers will run automatically. You won't have to do anything to that. You simply start up a new Sensu Server, connect it to your RabbitMQ and your existing Redis installation, and you're done. Easy. What about the Sensu API? Well, that's a stateless HTTP front-end, and you certainly know how to scale these things. It's just traditional load balancing strategies. RabbitMQ needs a bit more effort, but there are existing how-tos and documentations on how to build RabbitMQ clusters. And the same goes for scaling Redis if you are hitting load limits there. Unfortunately, Redis can only run with a single master, so you'll have a kind of bottleneck there, but you can at least run multiple instances of Redis for fault tolerance. And for that, for example, there's Redis Sentinel, and you can read up on that yourself. How about I have more than a single site? I have multiple data centers. How can I run Sensu with that? Well, there are 3 different approaches to that. And the first one is the most straightforward. You'll simply have your Sensu clients all over the place in your different data centers, and you decide to run a single Sensu installation in one of these data centers. And all the clients will connect to RabbitMQ, even over the WAN connection, and your dashboard will display everything in a single place. The advantage of that is it's a very simple architecture. It's easy to install. It's easy to maintain. You don't need any additional infrastructure. If you start a new location, a new remote site, you simply deploy your clients and get running. And your alert handling is centralized. That makes things easier as well. Of course, there are also downsides to that. Most of all, you can't distinguish client failures from connection failures. If your connection fails here, RabbitMQ won't get any client information anymore, and after 3 minutes, alerts will go off with a lot of clients having gone down, apparently. Also, you'll have a lot of TCP connections here, because every single client will open a TCP connection to your central RabbitMQ. And the dashboard actually thinks there's only one single location, and you won't have any information if you get some kind of alert from what data center that alert comes from. The second approach would be to duplicate RabbitMQ into every single data center. So you have RabbitMQ brokers on every single site. That will eliminate all these TCP connections because they will be local between your clients and the message broker. And that message broker will then pass on these messages to the central RabbitMQ instance, which won't require nearly as many TCP connections. You'll probably have the same problem if your data center connection here breaks. This, especially if it doesn't break but is simply unstable, you'll get a lot of keep alive requests that then get passed on, and you're highly recommended to model check dependencies so that you won't get a lot of secondary failures if, for example, a whole data center goes offline here. Of course, adding RabbitMQ instances will increase the complexity a bit, and still all machines seem to be in a single data center from the perspective of the dashboard. So step 3 would be having the complete Sensu infrastructure in every data center with the Sensu Server, with the central RabbitMQ, and clients connecting to that. And the Ujiva dashboard is able to access different Sensu servers, and of course, that will enable it to distinguish where did that critical event come from. Did it come from data center 1 or data center 2? But it's quite obvious, if that connection breaks, you won't have any insight into that data center at all anymore. And of course, that's maximum complexity because you need to replicate a complete Sensu installation in every data center you run. But it'll give you also the most detailed information about your data centers. So choose your own poison. There's also a way of achieving high availability, which makes sense by getting all the components of Sensu highly available. There's a nice how-to for that. And since I'm already providing you with some pointers, I'll also point to the community plugins. There's a huge collection of community plugins on GitHub with over 600 plugins so far by 80 or even more contributors. And it's a great source of getting checks, event handlers. There's also a thing that I didn't mention called mutators that take some event data, modify it in some kind of sense, and then put them back into the system. And of course, that's also a great possibility to learn by simply seeing how other people did it and getting inspiration about how to build your own checks and handlers. There are many ways to get support. For example, there's the Sensu channel on Freenode, with many people responding quickly and in a very competent way. There are mailing lists, for example, the Sensu users mailing list. There's also a Sensu dev mailing list. And as I've already mentioned at the start, there's also commercial support with SLAs and everything that you can get from Heavy Water. And with that, any questions?
Thanks for the presentation. How big is your data center?
We are at the moment we are running about 400 servers with, in average, I think 20 to 30 checks each. And we are still running a single Sensu installation on a bare metal host with the server, RabbitMQ, and Redis on the same host, and we have no issues at all. I think the server load is 2 or 3 on average, something like that. So we are very happy since we've been running Nagios on the same machine before and didn't get anywhere with that. As soon as I think we've crossed the 200 or maybe 250 server limit, things started to slow down, load increased all the time, checks were delayed by 1, 5 or more minutes, things like that, especially the checks that we like to run a lot of times, probably simply because Nagios triggers each check separately, even if it's, for example, a load check that we run on every machine. And of course, as you've seen, Sensu does that much more intelligently by simply publishing a single check request. All servers, please do a load check. And then it simply has to cope, of course, with the check results that come in. But that would any monitoring system would have that to do. Checks are running on time, and it's running greatly. So a lot of love on our side.
So how often do you how often do you execute checks then?
That depends on the check. There are checks that we do only every 10 minutes, for example, checking MySQL replication lag or things like that. There are checks that we run every 30 seconds, and there are a few checks that we run even more often. Okay. But that's probably not many. I think most of our checks get executed every 30 seconds.
Comparing Nagios configuration and Sensu configuration, do you see a benefit in the Sensu one? Is it more intuitive? Is it?
That's an interesting question.
Do you see the concepts? Do you see better concepts in Sensu than in the Nagios configuration?
I think I do. If I compare what Chef generates for Nagios with that what we get for Sensu, well, the Nagios configuration is at a single central place, so it's easy to look things up. Or, no, to be more precise, to find the right file where something is defined. But if you've ever tried to find the right check in your commands.cfg, that's not that easy. On the side of Sensu, you'll simply have a single check file in JSON format that says, for example, please, all subscribers, execute the following check, which could be, for example, a Nagios check, check underscore load, or memory, something like that. Maybe there are some placeholders in that, and so you can see, okay, there's something client-specific in there, and probably there will be a interval key that says how many times this check needs to be executed. And so you'll know in an instant what that check does, and you'll probably then simply have to look at your clients what will be inserted for the placeholders. So what are the specific limits and thresholds that are that apply to that client. So I think if I'd have to look at my Sensu configuration to diagnose something, it'll be much easier than with the Nagios configuration.
Okay, thank you.
One thing I gathered is that Sensu is basically open core.
Which is?
How painful is the difference between the open core and the enterprise version, and how hard is it actually to get the features that are in the enterprise version out of the open source community? Is it even possible?
Since the enterprise version is at the moment advertised as coming soon, it's hard to answer that question. But I think probably the most effort went into getting Sensu running on JRuby. They say it has higher performance because it runs on the Java engine, so I assume they are running it with JRuby instead of the plain MRI Ruby, which still is very powerful since it uses Event Machine as its processing algorithm or processing core. But I can't give you any hard evidence of how they compare. We'll have to wait.
How painful or how much effort is converting a Nagios installation, or especially in my case, checkmk configuration to Sensu? Not
At all. It's so easy because you can start with a single Nagios check. Take the same check, if it's an RPE check or if it's some other kind of Nagios check. You simply take that, create your check configuration with the command syntax. That's all there is to it. And Sensu will start using it. It'll simply say, OK, all you subscribers, please execute the following command, which could be any command on the machine. So this command could very well sit in user, lib, Nagios, plugins, something or else. And you've got your Nagios check, the original thing. You'll get the same results, but simply it's scheduled by Sensu, which takes a lot of pain away. And that's exactly how we did it. We took each single Nagios check and ported it over to Sensu, which will take you 10 or 20 minutes to get it running. And then we simply removed it from Nagios, as we saw that it runs in the same way. To be honest, there's still a Nagios instance running with us, and a few last checks are running in Nagios, but that's not because it wasn't possible to port it over to Sensu, but simply because Sensu took that much pain away that we put it on the back burner, porting the rest over as well. But that'll need to be cleaned up sometime in the future. But it's simply because Sensu, everything that's new goes into Sensu, and everything that remains with Nagios runs fine because it's only a handful of checks left. So that's another thing, how great Sensu works and how much it took away pain from the daily operation.
Thanks.
All right, thank you very much.